Hello, math magicians. Today we are looking at linear functions. So our goal is to identify, evaluate, graph, and to write linear functions. So please change that. Equations and functions have a good relationship, but today we're specifically looking at what's called functions. All right, so by way of warm-up, your job is to complete the table using the following flow chart. Choose a number, multiply that number by 9, subtract the original number, divide by 4, and see what you get. Do that 4 times. Then you're going to make a prediction about any number. Will this always be true? Make sure to explain what you can. I'll do one example here. So let's say, for example, I choose the number 7. Now I'm going to multiply by 9. Then I'm going to subtract the original number to get 56. And then divide by 4 to get 14. All right, you keep doing that with any number. And remember, you can choose negatives. You can choose whole numbers. You can even choose rational, that is fractions and decimals, etc. So any type of number you can go here. All right, after you've done that, our first order of business is to introduce you to a brand new notation. This is called function notation. So linear equations can be written as, we say y equals 3x minus 6. But another way to write this equation is using function notation. And we simply say this. We give the function a name. So for example, f of x. And instead of writing y, we write that. F of x equals 3x minus 6. Why in the ever beautiful world might I want to write it like this? You may ask, well, here is indeed why. Let's look at this. So the y is now substituted for this f of x. And just to recall how it's read, we read it like this, f of x. It does not mean f times x, okay? So try not to say f times x, because this is function notation. Okay, so let's see here. The valuable part of this is that you get to see your input and your output simultaneously. So if I'm going to evaluate g of x, and again, notice this, I changed the letter y. It's just a different name, like g of x, h of x, t of x, whatever we want. So that means I'm giving the whole thing a name. It's g. This function is called g. So let's see here. All we take is the negative 3, and we're just going to substitute it into here and here. So it looks like this. G of negative 3 is equal to negative 2 times negative 3 plus 4. Now, nothing to evaluate on the left side because this is the title, g of negative 3. In other words, what is the value of the function named g when I substitute a negative 3 in? So all we have to do is simplify over here. So negative times negative is positive 6 plus 4, and then out comes a 10. So notice how we write our answer. The answer is this. G of negative 3 is 10. The valuable part about this is that you see the input, you see the name, the specific function, the name of it, and you see the output. So quickly right here, I can see the point, as opposed to using just the y notation that goes like this, y equals, and then you plug in negative 3 in, and you get plus 4 there, sorry, and then you get your 6 plus 4, and at the very end, we get y equals 10, and we're like, oh, okay, y is 10. What did I put in again? Oh, you have to come back up here to see. So notice that we can just say g of x equals 10, or g of negative 3 is equal to 10. So if you need to understand a little bit, or you want to see it graphically, a function machine is often written like this, and this has no special shape. It's just an input and an output. Like we toss a bunch of things in and out come cookies, right? That's a function machine. Same thing here is if this were my function right here, g of x is equal to negative 2x plus 4, any number that I put in, for example, we just put in a negative 3, then out comes a positive 10. Now, same thing. If I put in a 0, then out would come a 4, right? Or if I put in a 2, then out pops a 0. So this is just a function machine. Put in your name and out comes your name backwards, or put in your name and out comes whatever, the first letter. So, okay, now it's your turn to practice these. Each function here, this one's called f of x, this is h of x, this is g of x, just different names for this particular function. So you're going to evaluate each one of these at -3 for each one of these. And please make sure to use the notation like we did up there, where we said g of -3 equals 10. So write it like that and come back here to check your answer. Now, we've checked your answers here, substituting a -3, out comes a -8, etc. I bet you have a question here on B. How did this work? So let's walk through it. H of -3 is equal to the negative of 2/3 times a -3 minus 11. All right, now notice what happens here. Double negative is positive, and 3 divided by 3 is 1. So we end up here, just to clean it up, is 2 minus 11. And now to finish that problem up, we get 2 minus 11 is -9, so h of -3 is equal to -9. All right, that's it for the first page. Enjoy your day.